Hello, in this video I'm going to show you how to find the inverse of a function. The function I pick is a bit more complicated than what we have done so far, but well, I can do it anyways. Here's the function y is equal to negative x to the power 4 plus 8x squared minus 1. So this is polynomial of degree 4, but in some sense it behaves like a polynomial function of degree 2, because I don't have any term in x cubed or in x. I sketched the graph here. I checked this with the calculator. This is how it looks like. So this is not a one-to-one function. I'm going to restrict the domain to make it a one-to-one function so we can find the inverse. We have 4 options for that, and I decided that I'm going to stick to the domain between x equals 0, where the function takes the value negative 1, and x equals 2, where the function takes the value 15. So I'm going to write over here what is the domain I'm restricting the function to work is between 0 and 2. And we can also write, because it's going to be useful, that the range is between negative 1 and 15. So if we want to find the inverse of this function, we're going to switch the names of the variables. We're going to say that x is equal to minus y to the power 4 plus 8y squared minus 1. And we're going to see that this, as I say, behaves somehow like a quadratic function. So what I'm going to try to do is to complete the square. So let me take the negative sign outside. So we have y to the power 4 minus 8y squared plus 1. And I want to write this as a perfect square plus something else. So what's inside the bracket is going to be y squared minus 4 squared. Yeah, if I do this, I can write it here. This will give me as result y to the power of 4 minus 8y squared plus 16. So the two first terms are what we want. Just that we have this plus 16 we don't want, so we're going to need to subtract 16 and then add the 1 we had from before. So we have that x is equal to, outside the bracket we have a negative sign, and then we have y squared minus 4, all of that square minus 15. And I'm going to expand, multiplying by negative 1, to write that x is equal to minus y squared minus 4, all of it square, plus 15. Remember, what we want to do here is to isolate y. So I'm going to write the bracket with the y on the other side. Y squared minus 4, all of that square, is equal to 15 minus x. So that means that y squared minus 4 has to be equal to either the positive or the negative root of 15 minus x. I need to decide which one I want, if the positive or the negative, and for that I'm going to look at one more point in the function. In our original function, when x is equal to 1, y is equal to 6. So we have 1, 6 as a point of the function, so the inverse has to have the point 6, 1. So I want to see when x takes the value of 6, which sign I have to give. So y takes the value of 1. So if I write that over here, we will have that 1 minus 4 has to be equal to, I don't know what to put here yet, square root of 15 minus 6. But the square root of 15 minus 6, that's square root of 9, which is 3. And on the other side I have negative 3, so that means I need the negative sign over there. So far what we know is that the square of y has to be equal to, now I have the 4 summing on the other side, minus the square root of 15 minus x. Now again we have to face the same decision. We are saying then that y has to be either minus or plus the square root of 4 minus the square root of 15 minus x. So again, we need to decide which one of the square roots is good. So when y is 1, we want the other side to be positive. Whatever we have over there, we can check that we'll get 4 minus 3, because that's the square root of 15 minus 6 square root. So we'll get the square root of 1. So we need to put the positive 1 over here to make this to be equal. So what we are saying is that if I call my function f of x, with the domain I restricted before, the inverse function of f is square root of 4 minus the square root of 15 minus x. And we always have to give what is the domain of an inverse function. The domain of the inverse function is going to be the range of the original function, so from -1 to 15. So the only thing I have left to do is to sketch the graph to see how this is going to look like. Let's go back to my graph over here. I already have the line y equals x to use it as the line of symmetry, and I'm gonna just take the symmetric of a few points. For instance, when x is 0, y is -1, which means that when in the inverse, when x is -1, y is 0. So I have the point over here. Then I have the point 1, 6, that has to become the point 6, 1. So it's the point over here. Then we have the points that are going to be fixed, are the points that cut the line. And the last one will be the point 2, 15, being transformed in the point 15, 2, which actually I think it's outside the picture, but let's just put it over here. So, sorry, this point I have to ignore it because it's outside the domain. I just need to find the symmetric of this little piece over here, and it's going to look like something like this. So this is y equals the inverse of f. And that's it.